This will be part 2 of the Math 8 Semester 1 review. In class, we did questions 1 through 12. As you can see, they have already been done. I have attached these to Google Calendar. And if you're not sure how to do them, you can look back at Google Calendar for the first part of the review. What we're going to do is go ahead and continue with question number 13. Question number 13 states, match the expression on the left with the expanded form on the right. Really, there is no work that you need to show, but it's an idea that you need to understand the exponent rules that are happening. I would start with the very top one. Very top one is your 3 times a squared b to the power of 7. Unfortunately, all of these have your 3's going on. But, make it simple on yourself. You're looking for a squared. So you are looking for one of these answers that has 2 a's. I think it's pretty clear that this one matches this one right here. You should probably go ahead and also check if it's b to the 7th power, that there are 1, 2, 3, 4, 5, 6, 7 b's as well. Awesome. Easy. The second one is 3a to the power of 4, b to the power of 2. So again, look at your 2 possibilities that are left. And I happen down here to see a 3, because there's only one 3 there. And this answer has 4 a's, which matches, and 2 b's. So you know your final answer, as these will connect, but let's recall that when you have something in parentheses and an exponent outside your parentheses, it's kind of like the distributive property. Everything inside of the parentheses gets that too. So it's 3 squared. A is already to the power of 2, so it will be multiplied by 2. B is already to the power of 3, so it will be multiplied by 2. So that's kind of your extra bonus information there, because your final might not be that easy. Number 14 requires you to simplify using only positive exponents. There is quite a lot going on in the numerator and in the denominator of this fraction. Let's look at the coefficients first. Don't even bother with the exponents at this part. The coefficients, if you just had a fraction, would be 2/8. If you put them in your calculator using the ND button and then pushing enter, it would simplify down into 1/4. So what you really have going on here is 1 x to the power of 6, y to the power of 3, over x to the power of 5, yz squared. If I have a fraction, that is the quotient rule. The quotient rule means that I am going to subtract my exponents of like bases. These are like bases. So I am going to have 1 in the numerator. Let's make sure we have a 4 in the denominator. X to the 6 minus 5, because you take your numerator minus your denominator. Y to the 3rd power, because that's in your numerator. You have y in the denominator, but it doesn't have an exponent, so you can rightfully assume that it is 1. And then in the denominator, you're still going to have z squared. There is nothing in the numerator to subtract, so that z is going to remain in the denominator. Okay, when you do your subtraction action, that means you have x to the power of 1, y to the power of 2 over 4z to the power of 2. You can leave it like that if you want. That is completely legit. But if you would prefer, you can write it also as x y squared over 4z squared. Those two answers are the same thing. Let's make sure that you turned the page and you are on number 15. Number 15 asks you to simplify this statement, 4 to the power of 3 multiplied by 4 to the power of negative 6. Again, we have a common base of 4 being multiplied, so this is your product rule. When you have the same base and exponents, you end up adding them. You can certainly use your calculator for this. So it's 4 to the power of 3 plus negative 6. So it would end up being 4 to the power of negative 3. Well, negative exponents happen to be a big no-no. So what we need to do is we need to put that negative exponent into the denominator and write it positively. So 4 to the power of negative 3 is really 1 over 4 to the power of 3. Where do you get that 1 from? Well, you need something in the numerator, so the 1 is kind of a placeholder. That answer is sufficient. Number 16. We haven't done a lot of this in class because technically this would be something that we did in 7th grade. But it wants us to simplify that expression. Well, as you may recall, we're going to combine like terms. Think of this as 6 monkeys, negative 2 monkeys, 4 ninjas, and another ninja. Remember, if you have a variable and there's nothing in front of it, it really is a 1. Well, monkeys and ninjas, 2 totally different things, so you cannot combine them. But if you look at the variable and the number in front of it, 6 minus 2 is 4 monkeys. Then we have 4 ninjas plus another ninja, so you would have 5 ninjas. Be cautious. This will show up on your final for sure. Number 17 is asking you to simplify this statement. What we have going on here is 3x quantity x to the power of 4 minus 2. You may recall if you have something outside of the parentheses, it is like the distributive property. So really you are taking 3x times x to the 4th power, bring down your minus sign, 3x times 2. Well, don't get frazzled here. 3x times 4x, we have the same base, which is your x. Go ahead and write out your 3x. Well, this would be to the power of 1 plus 4 minus 3x times 2 is 6x. Okay, and then if you simplified that all the way down, that would be 3x to the power of 5 minus 6x. In our 8th grade career, we would stop here. When you get to higher levels of math, there's certainly more that you can do with it. And if you're curious, I can certainly show you. But in our 8th grade career, this is as far as we can go. So this would be an acceptable answer. Here is where we abruptly change units. This is a different section that we had learned. The directions say, how do you determine which side is the hypotenuse? Well, okay, we're going to use exponents eventually with this, but hypotenuse. What does hypotenuse make you think about? Well, hypotenuse should make you think about the Pythagorean theorem. A squared plus b squared equals c squared. The hypotenuse is your longest side. It is opposite the right angle. And we also refer to it as C. Really, the important thing that you understand is this one right here. It is opposite of the right angle. Number 19 asks, what is the Pythagorean theorem formula? If you were listening closely, you heard me say that the Pythagorean theorem is a squared plus b squared equals c, or your hypotenuse squared. That'll be really nice on your final if you have that formula memorized. On number 20, it's asking you what the different sides stand for. So this is your right triangle. This could be A, this could be B, and this certainly would be C because it is opposite of the right angle. But the question is asking you, what would A be? Well, A is certainly not the hypotenuse. It's a leg. B is also not the hypotenuse. It's a leg. C is exactly the hypotenuse because it is opposite of the right angle and it is the longest side of the triangle. We're going to go on to question 21. You're going to have to turn your page. The way that mine is formatted, I can just scroll down, but you need to turn the page. If Blake is standing 10 feet from a 12-foot house, how far away is Blake from the top of the house? Well, it's a word problem, so you know that Mrs. Reynolds is going to make the most awesome of drawings here. So here is a house. Yeah, that's a house. It is 12 feet tall. And Blake is standing, Blake's pretty tall, man, the way I'm drawing him, 10 feet away from that house. Please note that this is clearly not to scale because the 10 feet looks longer than the 12 feet. How far away is Blake from the top of the house? So we're looking for this measurement right here. This is going to be your right angle. So in this type of question, we are looking for the hypotenuse. Remember, our formula is a squared plus b squared equals c squared. This is one of those situations of plug and chug. You know A is 10, so you're going to square it. B is 12, you're going to square it. But we don't know c squared. We've plugged in everything we know. We don't know c squared. So let's follow along with what the question is asking us. Right now, we still have an exponent of 2, so let's go ahead and square it. 10 squared is 100. 12 squared is 141 equals c squared. So we've squared them. I'm going to grab my well, I don't really need to grab my calculator. If it's 100 plus 141, that's 241 equals c squared. Literally doing what the question is asking us. There's an addition sign there, so do it. Whole goal of algebra is to get the variable by itself. I have c squared. How do I get rid of a square? Take the square root. In your calculator, hit your second. X squared. Put in your number. When you put in your number, you get something, oh, that is nasty. About 15.52 blah, blah, blah. Let's go ahead and round it to the nearest tenth. So that is 15.5 feet is approximately, that's why I'm using your squiggle lines, C. Before I move on too far, let me remind you that this is a final, and if it is a final, retakes are not allowed. That is where the idea of the word final comes into place. It's your final grade for this quarter or semester in high school. Okay, number 22. In a computer catalog, a computer monitor is 19 inches. This distance is the diagonal distance across the screen. So another fabulous picture. There's your computer monitor. And we said it's 19 inches, so it is the diagonal. The screen measures 10 inches in height. What is the width? Now, I wrote x, and I'm fully aware that x is not one of our variables in the Pythagorean theorem, but I did that on purpose. A squared plus b squared equals c squared. If 19 is our diagonal, where does it belong? It is our hypotenuse, so we're going to have to write 19 squared. Now, in class, you will remember I have mentioned it doesn't matter if you call 10 an x, your a, or your b, as long as you don't call it your hypotenuse. So let's call 10 your a and square it. So we don't know b. This process is going to be different than your number 21 question process because I gave you what c is. We are going to go ahead and square 10 to make it 100. And we also are going to go ahead and square 19. Do it in your calculator. $19 squared is 361. Well, the whole idea is to get the variable by itself. We need to start taking away the easiest things to get rid of. This time, this is the difference. This is the difference between 21 and 22. Subtract 100 from both sides. So I have b squared equals 261. I would like to get the b by itself. It is being squared. The opposite is taking the square root. So b is approximately, in your calculator, do the magic process you know so well. Don't panic, it's going to look kind of nasty. We're going to round it to the nearest tenth, so it's going to be 16.2 inches. All right, number 23. Can the side lengths 5, 7, and the square root of 73 be a right triangle? Well, this has a little bit of a different form than what we're used to, but the idea is the same. Whatever a squared plus b squared is, it has to equal c squared. So 5 and 7, not that bad. Take 5 squared plus 7 squared. Well, how do we deal with the square root of 73? Well, parentheses, square root of 73, and square it. Put that into your calculator. And I think that you will find that that is just 73. Excuse me. Then we have 5 squared, that is 25, plus 7 squared is 49. If you add those together, that is 74. Those two numbers are not equivalent to each other, so are they a right triangle? Nope, they sure are not. Number 24, almost there. Construct a right triangle using the given line on the coordinate plane. So this will be on your next page. There it is. You are given 2 points. That really is your hypotenuse. So bring your line down. Oops, I went too far. You might as well, it's okay. And then bring your line back. So here is our right triangle. Label the lengths of the sides. Our vertical angle, our one going up and down, 1, 2, 3, 4. So that has a measurement of 4. And our one going across, 1, 2, 3, 4, and 5. Determine the length of the hypotenuse. Well, in this picture, that's really hard to count because you've got like parts of this triangle or this square here, a little part missing there. So again, we're going to throw this in to the Pythagorean theorem. 4 squared plus 5 squared equals your c squared. That happens to be the measurement across from your right angle. So we have 16 plus 25 equals c squared. Since we are looking for the hypotenuse, we can just go ahead, and the difference here is we're going to add those two together. 16 plus 25 is 41 equals c squared. Well, the whole equals idea is actually not really true. If you know your perfect squares, there is no whole number times itself that's going to be 41. And I want to get the c by itself, so that means I'm going to have to take the square root of both sides. In your calculator, second, x squared, type in 41, and then hit your conversion button, and it's a nasty looking decimal. Let's round it to the nearest tenth. So it's going to be 6.4. If you want to label, really that is units. So this is the second part of your final. If it's on your study guide, it will most definitely make it onto your final. Please review these items as well as numbers 1 through 12. We'll get some online practice after we're done with this. And you might want to consult the calendar to see what finals are on what days. Really put some effort into this because this is everything we have done since August.